আমি স্টার্ট করছি তাহলে। Good morning, everyone. I, Mayurakhina, welcome you all on the day 2 of the webinar on the introduction to Python. We learned a lot yesterday on the fundamentals of Python, and today we are going to learn some more features on Python. Okay, today we have Dr. Shayanti Talukdar, our IQSC chairperson, with us. So first, welcome you, madam, and I would like
Thank you so
to
much.
request madam to say a few words on the webinar. Madam,
Thank you, Mayurakshi.
over to you.
Okay. Thank you. Good morning, everyone. Myself, Dr. Shayanti Mukhopadhyay Talukdar, IQSC coordinator of Surampur Girls College, welcome you all to this webinar on behalf of the principal of our college, Dr. Shoma Roy, IQSC members, webinar committee, the Department of Computer Science and Mathematics, and all other professors and staff of our college. The Department of Computer Science and Mathematics, in collaboration with IQSC, have organized a 2-day state-level webinar on Introduction to Python Programming. We have with us an eminent speaker, Dr. Orunabh Odhikari, Associate Professor, Department of Physics, West Bengal State University. We also have with us Mr. Soumen Mukherjee, Assistant Professor, Department of Computer Application, RCC IIT, Beleghata, Kolkata. He will be conducting the interactive session. I welcome you both wholeheartedly to this webinar. We have already had an illuminative, exhaustive, excellent session yesterday in which the fundamentals of Python programming have already been laid down with every detailing about the basics of Python. Therefore, a well-analyzed platform has already been set for the students, for the beginners, and for any earnest learner of Python programming. I'm extremely hopeful. We are all looking forward to another session of eloquent, lucid presentations today. Thank you so much. A few words on Python. Python is an interpreted high-level general-purpose programming language created by Guido van Rossum and first released in 1991. Python's design philosophy emphasizes code readability with its notable use of significant white space. It has a wide range of applications from web development, building a desktop GUI to scientific and mathematical computing. Python is popular for its simple and relatively straightforward syntax. Its syntax readability increases productivity as it allows us to focus more on the problem rather than structuring the code. This is a comprehensive guide that explores the reasons one should consider learning Python. Reasons to choose Python as first language would be: 1. Simple, elegant syntax. 2. Not overly strict. 3. The expressiveness of the language. 4. Great community and support. And lastly, it's user-friendly. If you are getting started in programming, I would say for the students and the learners, if you are getting started in programming, Python is an awesome choice. You will be amazed by how much you can do in Python once you know the basics. It is easy to overlook the fact that Python is a powerful language. Not only is Python good for learning programming, but it is also a good language to have in your arsenal. Python can help you to get started in everything, whether it is changing your idea into a prototype, correcting a game, creating a game, or getting in machine learning and artificial intelligence. I wish this continuation to the second day a great success. May all the students, participants, learners, as well as teachers be extremely benefited by the in-depth knowledge and guidance imparted by the scholar. Thank you so much. Thank you, dear audience. Thank you, all the participants. I wish you good and sound health. Stay happy, stay safe. Thank you so much. Over to Mayurakshi.
Thank you, madam. Thank you for your precious words and encouragement.
Thank you.
Now I request our speaker, Dr. Orunabho Udhikari, to please start today's session. Over to you, sir.
Thank you very much, and good morning to everyone. Now let me start my presentation, and please tell me if I am audible as well as my presentations are.
Yes, sir. You audible.
You can hear my voice. And what about my presentation? Can you see this?
Yes, it can be seen.
Can you?
Yes.
Yes, sir. Yes, sir. We can hear you.
Okay, thank you.
course.
Now, yesterday I forgot to mention one thing which may be important for the students, that in order to run Python code or develop small codes in Python, you need not have a laptop or a desktop. You can even work with your Android phone. In the Google and in the Play Store, you can have many Python interpreters. I would particularly recommend two interpreters. One is called QPython, and the other one is called PyDroid. Both of them are very useful. So if you don't have a desktop or a laptop at your access, then you can try this, even this Android-based Pythons. Okay. Now let me continue. Yesterday, what I was doing, I was discussing about the modules. And I have already discussed about two modules. One is that math module. First of all, I discussed about underscore, built-ins, underscore. Then I discussed about math module. Then I also discussed about a CMath module. Math and CMath are almost equal, but CMath is capable of handling the complex numbers. Okay. And as I also told you that Python has an inbuilt complex number facility. If you have to deal with complex numbers, you can always deal with Python. Python can deal with complex numbers. Now, there are other modules like time. I have already talked about time module, like import time. It's a module. And in this time module, there are other functions like time.time. That is, I want to run time function from time module. This will give me some number. This is, I told you, this is the number of seconds that have passed since the 1st January 1970. And if I want to read it, read this time in a more readable format, then I would say time.ctime. That will tell me exactly that what time, date, etc. we are having. But this time, that time is very important, as I showed you yesterday, that you can, within the program, you can run it at any time. So that is something like looking at your wristwatch. And at some other part of the program, you run it once again. So that is looking at your wristwatch once again. And the difference between these two time will tell you how much time the program Python took to execute this part of your code. So it is very important. And there are other facilities like time.gm time. This is Greenwich Mean Time. This is Greenwich Mean Time. It is whatever is Greenwich Mean Time. If you can see it, time structures tells you that 2020, etc. And it so it is a Greenwich Mean Time, you can see. This is it. So there are many other facilities, and the important facilities is time.slip. You can understand function of this time.sleep. What does it do? Because if you have to stop your program, pause your program for some time. I mean, if there are many cases where we want to stop execution our program, or rather pause the execution of our program for some seconds. We can always use time.sleep, and within the as an argument we will give the amount of time in seconds. So there are facilities like this. So this is all about time, and you can explore more. And the next thing is user defined. Sorry. Before user defined function, yeah, this is more interesting. Regular expression. Regular expression is more interesting. Regular expression is what is regular expression? They have already told you that if A is a string, say A, B, C, G, G, C, A, T, T, A, C, G, DNA sequence, and we have S equal to, say, TCG, ECG. So we want to ask whether this S, the substring, is present in the main string. So what we do, we say A dot find S. And that tells me 3 is at the third position, 0, 1, 2, 3. I can see the 0, 1, 2, 3, this substring is present. But then I have to specifically tell you what exact. Any question? Any problem? I hear a sound. I mean, did you want to tell me something? Can I continue? Okay, thank you. Thank you, Shobhan. Now, in this case, see, I had to specifically tell that I want this substring TCG. But there may be a case where we can give a more complicated kind of a substring. Look at this. Look at this. Instead of the difference between this is here I gave the substring TCG. Here I gave a substring TC.T. Definitely, if I try it here with instead of A, if I give T dot T, it will try T dot C dot T, like this one. This one, if I give it here, and try to run this program, it will say -1. -1 means that there is no such index where it is present. It is important. -1 here doesn't mean that it is at the last position. It says that when find gives you a -1, it means that it hasn't found it. It is not present at all. So that means that C.T string apparently definitely is not present here. But instead of running it in a normal string find, there is a module called RE. RE stands for regular expression, right? So if in the regular expression, if I give this one, then the whole meaning of the substring changes. So what does it mean? It means that you are looking for a string which starts with C, which ends with T. It's a three character code. Substring that starts with C, ends in T, and there is one character in between that can be anything. One character in between that can be anything. So it has to be 3-character string, starting with C, ending with T, and you can put anything in between. So it's a more complicated thing. So just run this. See, look at the original string. No, this is S. This is S, and see, this is our output. So this CAT and CBT, where is CBT? CAT, CBT, these are all fetched out because you have given a instruction like this. So if you want, say for example, 2 character, I mean total 4 character string having 2 intermediate characters, I mean you can put another dot here. So it will fetch out 4 character string. Let's see if you can have this. Yeah, we are having CAAT, CCCT, CACT. But what if I give, for example, C dot 2? I mean, it's not necessary that, I mean, it has to be, there should be an N character. So it fetches out many other things. No? Okay. So what we have learned that in the regular expression substring, if I put a dot, that means any character, but just 1 character, but that can be anything. So you substitute with anything. Now, if I put star T, let's see what happens. See, what does it mean? This means that this is dot means anything, but star means any time, anything and any time. So you can put any number of characters here. That should, the only restriction is that the substring should start with C and end with T. And you know, Python, what Python will do, for example, this could have been something like this. It starts with C, ends with T, and there's 1 character in between, but Python doesn't stop here. The rule of the game is, if you give a start string, I mean expression, and the expression is, Python will find out the longest such match. So Python found out the longest such match, which started with A, and it has put everything in between and ended with T. So that's it. So now we can look at the slides to see the, yeah, we can understand. So this is C dot start T would mean anything, anytime, anything, any number of time. So you can see that it found out the maximum number of time. Now, if instead I put something like C dot T, now what that would mean, this dot would mean any character, 1 character. So you can put 1 character here. If I put C dot T, that will definitely tell me that I'm looking for a 4-character match, which starts with T, ends with T, starts with C, ends with T, and you can put any 2 characters in between. But what this qualifier is, look, like star is a qualifier of this dot. Star says that you can put anything, anytime. And this exclamation is another kind of a qualifier. It tells you that about this dot, about the last dot, the qualifier is exclamation mark, and it says that you can put 1 character or 0 character. So what finally boils down that you can have, due to this dot is mandatory, so you have to put 1 character here, and this dot comes with an exclamation sign. That means you can put 1 character or 0 character. So that would mean that your start string may be a 3-character long or a 4-character long. But it will start with C and end with T. See the matches? Okay. And what are the other things? Like if you put /D, like if you put /D would find out the digits. So if your strings are there, you will find out the digits, right? Now, remember there is a R here. Why should I give R? That is very interesting. You very well know, being there are a lot of participants here in this workshop from computer science background. So you know that typical our escape sequences like /T. That means that /T means that we are referring to the tab character. /N. That means that we are referring to the new line character. So escape sequence is a predefined thing. Now there is no such thing. When I used it in this regular expression, I don't want to mean that /T is an escape character, escape sequence. I don't want to mean this /D is an escape sequence. So I want to Python, if I don't give the R, then Python will try to interpret /d as an escape sequence. Try to find out whether /d means something like /t or /a, if there is something called /t. If it finds out, then it will execute that, and otherwise it will give me an error. But I wanted to tell Python that don't try to interpret this /d as an escape sequence. That is why I put this R over here. R would mean that don't interpret /d as an escape sequence. Try to interpret it as just a raw thing. So now /d stands here in case of regular expression as digits, right? Okay, so it will find me all the digits. And what is about /t plus? /t plus will tell me all the successive digits. So see the difference between when I say give /d, I find 1, 2, 3, and then 5, 6, all as separate matches. But whereas when I give /t plus, I find 1, 2, 3 as a sequence of matches. That is a single entry. 1, 2, 3 comes here, and then 2, 5, 6 another sequence of match. So consecutive matches. So I group it here. So that is it. And what is capital D? The rule is if small d means digit, capital D would mean something other than digit, not digit, not digit. So if you want to put a not, you just make it a capital. So D is digit, capital D is not digit. So it finds out all the non-digit characters, right? And W is alphanumeric characters, right? And W plus would mean successive alphanumeric characters. So, and capital W, apply the rule. If W is alphanumeric, then capital numeric W would be something other than alphanumeric, something which are not alphanumeric, and the plus would mean the successive ones. That is why two hashes are taken together as a single match. Okay. And D plus is already explained. Now, what is D plus tells you something like this. You apply D plus, what is D? D is the digits. So you get this 1, 2, 3, 2, 5, 6, etc., etc. But just look at this match, 1, 2, 3, 4, 5. So a 5-character match. But if you give this kind of a command, that would mean that it's a digit. But this extra thing after the digit says that your the successive match would be 1 character long, 2 character long, 3 character long, or 4 character long. Maximum 4 character long. So 1 to 4. So your lower limit is 1, your upper limit is 4. It has to be, although consecutive, you cannot have more than 4 character match. So this string, which is 2, 1, 3, 4, 5, which was a 5-character thing, is now split into two different matches, 1, 2, 3, 4, 3, 4, because you are restricted to 4, and the last one is 5. So that's it. And see, this is something called another kind of matching, where you put this kind of a thing, and it's very, very obvious. You can read it. This is a string, I call it line, and that gives me a sentence, and try to read it. You can read it. It says that anything, anytime, and then there's an and. You look at and the word before the and, it can have anything and any character, but the word before the particular word before the and would be your first match. And the word before the second, following the and, will be your second match. And you can put anything again. Again, try to look if there is another match, another and in the string. And the word that precedes and is your third match, and the word precedes your follows your and is the fourth match. So in the whole string, we are talking about 4 different matches. So they're designated by the brackets, first brackets, parentheses. So these are the 4 matches, and the matches are defined as a word preceding and following and there should be another and the word preceding and the following and are the other matches. So and the syntax is re.match. So if I do and if M means that if you find such match, if M is true means that if such match is found, then just print this. And if you do that, you'll find that the result is physics. The first match is physics, the second match is computer science, the third match is statistics, the fourth match is mathematics. I think I have the program written somewhere here. Yeah. So I run this program. This is the original statement line. And the first match physics, second match chemistry, third match statistics, fourth match mathematics. So I could fish out those things. So this is all about regular expression, and you can explore again other possibilities with regular expression. Now I come to the more interesting concept of user-defined function. And so I think all of you have exposure to some of the other language. Some of you are quite experts in C, and some of you are experts in Java. So you know how to write user-defined functions. I only have to tell you the syntax here in Python. First of all, if you have to define a function, there is no restriction that it has to be at the beginning of your code. No, it should be before you call it. So where it can be at the 100th line of the program, but before you call the function, it should be defined. That's it. And now the syntax is def. Def is the keyword that you are going to define a function is def def, and there should be a name. Here the name of the function is ff, and within the bracket you should put the arguments. You know, the arguments, and as I said, the ubiquitous statement structure is that after this function and the name, you should put a colon. Colon will tell you that you are going to define a function, and whatever is the body of the function should be within the tab or the indentation. But there is a mistake. Please be aware that this return should also be the part of the indentation. This is wrong. This will not work. I just show you this one, right? I think it's already there. My function is okay. I have a function here. My function. This what does it do? I mean, it is quite instructive. I have a function called ff, which has 3 arguments: x, n, and m, and it calculates a very simple thing. It calculates the m into x to the power n and returns me the y. So I run this program. There is no output because I didn't call if. But the beauty of the thing is that the whole thing is live in the interpreter. So ff is already defined. So I can tell you ff of say 2, 3, and 3. Gives me a number which is equal to, evidently m is 3. So 3 into, it actually calculates 3 into 2 to the power 3. 2 to the power 3 is 8, and 8 is 24, right? So the program is working fine. Now, so, and as we know that these are called this actual argument, but that gives me a chance of showing you few other things, like here. Whenever I call this program, I have to specify 3 arguments. But we have seen in many cases like range and many other instances in Python where there's a function which I can call with 1 argument. If I like, I can call with 2 argument or 3 argument, and there are many such things. Okay, so there must be some way to do this. It seems that whenever I have to call ff, I have to specify all 3 arguments: 2, 3, 2, 3, and 3. If I want just try to call it just with 2 and 3, obviously that will be a wrong thing to do. It says that missing 1 required positional argument m. Okay, but let's try m equal to 3. Just put that there. Now I can of course call it like f equal to say 2, 3, and say 4. I can have a value. This value is of course 3 into 2 to the power 4. 3 into 2 to the power 4. 2 to the power 4 is it so? m equal to 3. No, it's 4 into 2. This is 4 into 2 to the power 3. 4 into 2 to the power 3. 2 to the power 3 is 8. 4 into 8 is 32. Right. Okay. Now the point is, if I call this function ff with only 2 arguments, say 2 and 3, this time it does not give me an error. It doesn't give me an error. It doesn't give me an error. What does it do? What does it do? If it doesn't give me, see the difference. Difference here, it was saying that it is an error, but not this time. It is not giving me error because I've introduced this extra part. M is equal to 3. That means if I don't specify a value, if I give two values only, x and n, 2 values only, they will be interpreted as the values of x and n, and the value which is missing will be interpreted as the value of m, and it will take the default value 3. So it's called calling the function with default arguments. Calling the function with default arguments. So, and if I can also have n equal to say 2, save and run. This time I'll be having the freedom of calling the function even with simple 1 argument, because the 1 argument that I specify will be the value of x, and the other arguments will be taken their default values, n equal to 2 and m equal to 3. Now the point is, can we have a function where all the functions will have, all the arguments will have default values? No. You at least have to have one positional argument where you have to specify the value. So all the values cannot be predefined. I mean, default values, at least one value should be positional value number 1. And the positional argument should precede the default arguments. So if you have some positional arguments, that should be written before the default arguments. Default arguments should be kept later on. And now the point is, if I specify now, if again 2, 3, 4, then you see that these 2, 3, 4 will be assigned sequentially, as 2 is the value of x, 3 is the value of n, and 4 is the value of m. Okay, I'm happy. But the point is, if you can imagine that you have written a function which has, say, 24 arguments, and in most cases, most of the arguments have default values. Say, out of these 24 arguments, you have, say, only 2 or 3 positional arguments, and all other arguments have their default values. It's quite possible. Now, you want to change run the program, not with the default values. You want to change the default values. As we can see that we can run this program with ff2, so we are using all the default values, whereas if we run with this, we are using the default value 2, the positional value, and 3 will be the default value, and that will be a non-default value, and that will be taken as the value of n. When I say run ff2, 3, the value of 3 will be the value of n. Value of n, which is the first non-default value, first default argument. So now my problem is, I have 2 positional arguments. I've specified the values of these 2, and I also want to specify a non-default value of the 21st argument, for example. This is what I wanted to do. So far, what we have understood then, because if I've given 2 positional values, and all values are default values, and I actually want to change the non-default value to the 21st argument. But then do I have to give the values, default values to all the intermediate arguments? This is too bad. Because it seems that if I am interested to change only the value of m, but want to keep the default value of n, but then also we have to say ff, say 2, 4. Then only the value 4, non-default value 4 will be assigned to m. Here I have to keep the default value. This is bad. This is bad. because I want to change the non-default value of an argument, which is not the first one or not the second one. It is some 19th one or the 7th. I have to specify all the intermediate values. No, you can do that more easily. You can do that to an m equal to 4. You can just say what is your. It also does. Therefore, if you say m equal to 4, then this 4 is changing this one, not the intermediate one. So if you want to change one of the 19th default argument with a non-default value, you simply have to know what is the name of that variable, specify that name equal to specify the non-default value. That's it. So this is called keyword argument. The style of this called keyword argument. So default argument and keyword argument, and these things are discussed now. So you can see that. So I don't think I have much to. Yeah, there's one more interesting thing about this, that this is a function which evidently takes two arguments x and y and calculates sin x plus cos y as y1 and y or minus x square as y2, right? And this is a more interesting thing. It returns two variables. You remember that most of the programming languages, most of the common programming languages, we can return only one quantity. Here we can return as many quantity as we like. We can have multiple values as returns. So we can run such a program which will have two arguments, two returns. For example, yeah, this one. This is the program. So I can always run this. I run this program, then the mystery will be solved. Why there are some unable to? Okay. See, program is running, and what is giving me the output of FF. Output of FF is there are two outputs. You can say 0.042 is the value of y1 and 0.735 is the value of y2. So definitely it is returning more than one thing to me, and so the part of the program is, I think, clear to you. But the mystery, in fact, even Python doesn't return more than one quantity. It actually returns one quantity. And apparently, although it means that you are actually trying to return more than one thing from the function, actually I told you that if you specify two variables or two things with a comma in between, then there is something called packing. So actually these two things are packed into a tuple. So actually Python is returning you a tuple consisting of y1 and y2, and that is evident in the output itself. You know, this first bracket over here and the first bracket over there, it actually tells me that it actually returns me one single quantity. It packs the two return, apparently these two things that are asked to return y1 and y2, it packs them into a single the tuple and returns me the tuple. But I can be ignorant about that. I can be very well ignorant about that. I can store that I can be v equal to ff of say 2, 3. I can run. I can have value of u and value of v separately, and I can, being a bit naive, I can think that I have got two independent things as return. Okay, that's it. The scope of a function. So as you know, I mean, these are very well known that the variable name x here, the argument name is x. In the main function also I give the value of x, but as you know, there is no restriction. There's this two names have to be equal. Actually, even if you give the same name, they are actually two different variables. The x in the caller program and the x in the of the function are two different variables. Though they can have the same name, they're actually two different variables. And I'll give you the slides. You can see that although I can change the value of x is given here as 2, and in the program I've set it to 4, but then in the main function it still remains 2. That's quite obvious because x here is a local variable, and all this name match is quite incidental. It doesn't have to match, and even if match, it doesn't matter. Okay, now global scope of a variable. Here you can see that within this function I have used a variable x, which is definitely a argument. Through argument I got this, but what is the value of a? The value of a within the function is not defined. If you have a variable whose value is not defined in the function, then it will look at the caller function. Is anything defined in the caller function? The value of a is defined in the caller function. It will automatically use that. But here the name should match. In case of argument, the name can be the match of the name is incidental, but here the name has to match exactly the name of the global variable. But of course, you cannot change the value of a over there. If you want to change the value, say we want to write something a equal to 3, then immediately it will interpret that a is a local variable of that function. Okay, so global variable, it doesn't have the function doesn't have the right to change the variable. Of course, you can give the access both to the caller and the function by defining an actual global, so where you put within the function statement a global a here and global a here. If you put global a here and global a here, then both the caller and the main function can change the value of a. It's like a common variable. Both of them have equal access to the function, but that is the use of that global variable is highly discouraged. That is not a good idea to do. So, but in order to exemplify, I said that, and the default argument is already discussed, and the keyword argument is this is called lambda function. Lambda function. But before lambda function, let me try out something called map. Let me show you something called map, because I'll give the example with map. Okay, let's have a small function. My function, yeah. Okay. I know this is a function which can be called with one single variable. Okay. Now let's have a list. Say list is say 2, 3, 1, 5, -1. Right? And then I can have map of ff over a, and then I could call it the list. Yeah, it's working. So you see what happens. Actually, every element of list is taken, and the function ff is executed with the argument taken from the list. So original a list is this. So 2 is taken as the value of argument of ff, and the function is executed, and you get the value. And so another map, another list is created with the values taken from this. It is almost equivalent to a b equal to say least comprehension of say ff of x for x in a. It does the same thing. It gives the exactly same thing. Now, sometimes this one is faster, sometimes the other one is faster. It depends upon, I mean, I'm not sure which one is to use what. I mean, there are two alternative ways, and in some cases one is faster. Sometimes the other one is faster. So I mean, there are two ways of doing it. But okay, there are some advantages of map when your function. I mean, list is very long. Say you have 1 million entries, and you can use map, and the beauty of map is that map doesn't create a list as such. We are creating a list with this. It keeps a kind of things ready when you need an element of that. For example, if you just say map of FFA, it knows what you have asked it to do, but it doesn't create the list. It is ready with the idea of creating the list. When you call a function, say you call the 100th element of the list, then it creates, according to your prescription, it gives you the 100th value. The advantage of that if you want to do a list comprehension, and if A has 1 million numbers, then B will also have 1 million number. Your memory space will be jammed, but you may not need all this 1 million number. Maybe you are interested with the 100th element and the 200th element and the 1000th element of that particular list. So using map is better, because map doesn't create the list beforehand. It understands your instruction, it gives ready, and if you ask the map to give the 100th element, it gives you the 100th element. So not all the 1 million numbers are created and kept for you. So that is the advantage of map. Now, from that, look at this example. So this is a function, and that we have created a list X, and we are executing map with this ff function with X. So what is the structure of map then? What is the syntax of map? Map will take two arguments. The first argument will be the name of a function, and the second argument will be an iterable, preferably a list. Okay, a kind of iterable. Now I do the same thing here. But in order to have a map, run a map, you need to have a function, predefined function. It is always possible that I don't predefine the function. I define the function on the fly itself. For example, in this example, I've done another map on the X, but with a function 1 by 1 plus X. Function is defined as 1 by 1 plus X. Take any value of X and do 1 by 1 plus X. But this function is defined on the fly by this kind of a syntax, which is called lambda function. Lambda X colon 1 by 1 plus X. That means you are defining a function on the fly. You are defining a function of X, which is equal to 1 by 1 plus X. So either you have to have a predefined function using def and has a name. You can call the name over here, or you can define a predefined function. I mean on a function on the fly. That's called lambda function, and that is not restricted with map. Wherever you want, you have to give the name of a function. You can have that function predefined with a pre-existing name, or if it is easier for you, you can always give a lambda function. You can define the function on the fly and give it there. Okay. And the remaining part of this slides I won't discuss, because that discusses object-oriented programming, and I've given the slides already to you. So those who are familiar with the object-oriented programming can see I have an example of defining a vector class, and you can go through it, and if you find any problem, we can always discuss in the WhatsApp platform, and I believe that WhatsApp platform will remain active for some time. Now at this point, I should take a small break and go to the next part of my talk. Your screen, okay. do you have any question? I mean, I can take questions now. Oh, you didn't catch map. Okay, let me repeat it. See this example. As I said, you have a list over here. A is this, and now you have a predefined function ff. This is your predefined function ff. Now, what you want to do, as you know that ff is a function, we said two default arguments, so you can call ff with one single argument x. Now, I can my aim is to operate this ff on every element of A, and thereby create another list. That's it. So my syntax will be this. So by this way, so it is that way, this is equivalent to this. That on every element of X, you execute ff, and consequently you generate a list. But I said that there's a small little difference between using map and using ff. For example, if you don't give this list portion, if you just keep map portion, then what is generated is not a list. It's called a map. Map is not a list. Map is something which I can say that it is ready, it knows what to do, but it didn't do. It didn't create a list. It knows what exactly you have to do. Now, if you say that you want to have the 100th element of the consequent list, then according to the prescription, it will readily calculate the 100th element and tell you that this is the element. You know, it is always ready beside you. It knows what to do, but it didn't calculate. It will calculate only when you will ask it to calculate the, say, the 100, what is the 100th element, what is the 150th element, what is the 200th element. What is the advantage of that? That if you are dealing with, say, 1 million number, then after executing this what do you call list comprehension, you get another 1 million number, and probably you won't be really doing with this 1 million number. You are not interested. You will be interested in some of those 1 million numbers. Then it's always better to use map. Map doesn't create those 1 million numbers. It is ready, and it will give you those numbers, say the 100th number or the 150th number or the 200th number. The numbers that you want, it will be readily give you. I mean, that's the better part of ff. ff doesn't create a list by default, but in this case, I've asked map to convert everything to list, so I can see that what it can do actually. Okay, that is the key point. Any other question? I can't see. Showman.
Yes, sir. One of the question is not on map. It is on nested function. How the nested function can we can do nested function? You can write nested function.
Nested function means if
function under function. We can do it. We can create a function under this. By indentation, we can write another function. It is possible. I have just shared it. Okay. I have shared it. Okay.
There is no problem. I've never used such thing, but recursion and other things you can always do. Okay. But then if there is no more question, then let me proceed to the next part of my talk today. Sorry, just a minute. I have to open another slide. Srirampu 2. Yeah. Now, this brings me to something that I really love, because, you know, as I told you that I'm not a computer scientist, I'm a physicist. And as a physicist, my basic aim is to play with the numbers. And Showman is my student, and Showman unfortunately is my student, and Showman also plays with numbers. And so we play with numbers, we do all sorts of calculations with numbers, numerical calculations. So the people who are interested doing numerical calculations, particularly mathematicians and physicists, I would say that you cannot do away with NumPy. NumPy is something that that is your magic thing in Python. So without NumPy, you cannot do anything. So now the point is, where is NumPy? If you are working in say QPython in the Android, or if you are working with Linux, or if you have downloaded Python from python.org, no, your distribution doesn't have NumPy. Of course, Python XY has, Anaconda has, and of course, if you cannot, for some reason or the other, you cannot work with any of them, then there are other ways of importing NumPy, installing NumPy in your computer that we will discuss in the WhatsApp group. Let me just assume that you have either a Python XY or Anaconda, so that NumPy is already installed in your computer. The first thing that you have to do, you have to have a list, and the thing that you do is np.array list. If you do that, then the new thing that if you have a list, and you just let me show this. Now, usually the thing that we do always, we call import. It's an almost global style, import NumPy, but we doesn't stop here. As np. This is the extra thing that I didn't talk about yesterday, but you can always do that. Import a box and give a short name to this box, because always we have, next time onwards, we are not opening the box. We are not pouring down the functions from the box. We are keeping the box on the table. So always we said we have to refer to as NumPy. Anything that you use within from the NumPy. So NumPy has 5 characters. We can at least the best thing that we can do, we can make it 2 characters. So without we give a shortcut name to this NumPy. So the whole statement means that import NumPy, bring the box, and give it a small name, np. So here onwards, if I say np, it will understand that I'm referring to the NumPy box. And then let A be a list, say 1, 2, 3, 2, 1. Okay, and then I said np.array. Sorry, b equal say a equal to np.array. There is no restriction, of course, that I have to give a. That's something I preferred. Now these two things are different. What is a? How do I know? I say type a. Type a will tell me what a is. It's a list. And what a is? NumPy ND array. Now this ND array is a very interesting statement. ND means n-dimensional array. N-dimensional. So it can be n-dimensional array. Now in this particular case, what is the dimension? I can understand a.ndim. It's the 1. So it's a one-dimensional array. The particular array that I've tried with is n-dimensional. And what are the things that I can know? Then what is the data type of this array? E type is int32. It's also integers. And what is the size of the array? 5. Okay. And what is the shape of the array? Five comma blank. That means the one-dimensional array having 5 elements. Okay, that's fine. Now, but still it is not clear what is the advantage of working with array. I'll come to that later on. But then let me tell you that there's a difference between array and list. What is the difference? The first apparent difference is that, you know, the people who are familiar with C, Fortran, Java kind of a language, I mean, they are familiar with the concept of array. But as I said, that list is not array. List is, it looks like an array, but it is different from array. In which way it is different? That every element of array can have different data type, which is not strictly not true for array. Remember, the array in C, it has to be either a float array or a integer array or a character array. You cannot have one character integer, the other character string. But in case of list, everything is possible. And the second restriction was that the array, the total size of the array, total number of elements of the array is fixed in case of C, or in case of Fortran, every other case it is fixed. But in case of list, yesterday we have seen that we can increase the list by appending, by inserting, and we can make delete some of the elements by popping, by removing, etc. So I mean, even the number of elements is not fixed in case of list. So list is a very flexible thing, but array is not. Array is that way very similar to the C type thing, that every element should have the same data type, as in case it is an integer data type, and the other thing is that it has the fixed number of elements. The number of elements is 5. A is created as an array with 5 elements. Unless you reassign A to a new variable, you keeping the A as such, you cannot do it in a different way. I mean, of course, what you can do, you can change the A. You can change the A. You can change the A. You have increased A, and you are redefining A. It's a reassignment. Definitely now number of elements have changed, size, number of elements has changed, but that's a different thing, because you are reassigning the A, the name A to a new array. It's not the same thing, but this, unless you do that, you reassign the whole thing, keeping the entity of A intact. You cannot add some more elements or remove some of the elements. Number of elements of the array is also fixed. Number of data type of the array is also fixed. Now, like any other thing, like you can do a reassignment, of course, is possible. You can say A of 0, the first element of is now -3. Quite possible. Look at array. Array which was the first element was 1. Now first element is -3. That's quite possible. You can do the slicing the way you do, like b equal to A, say 2,4. That would mean that if you start with the second element, it is 0, 1, 2, the second element, and stop before 4. So 0, 1, 2, 3, 4. So I should get this one, I think. See, I'm right. 0, 1, 2, 2 and 3, it has to stop before 4. So even this slicing is done the same way, but there is an interesting difference between slicing and slicing in list and slicing in array. What is the difference? Okay, let's reassign some value of B. B of B0. Let's B0. The first element of B, let it be, say it was 3, now make it 17. Definitely B is 17. And I expect that nothing has happened to A, but has changed. So all you have to understand that you can do a slicing definitely in array also. As you can do a slicing in list, you can do a slicing in array also. But slicing in array is a view. It's a zoomed kind of a view, right? It's a zoomed kind of a view. It is not an independent existence. It's a zoomed view. You are trying to view the part in a zoomed window. So if you do a change in the zoomed window, the original thing is also changed, right? So, but if you're interested to get an independent copy, it's just the same thing. You remember np.copy. Now, what is B? Is this? What is A? Is this? Oh, sorry, it's not A. A. A is this, and its copy 17 to 2 is now 2 to 3 0 1 2. So 17 and yeah, 17 and 2. Now I say that the last element of B is now reassigned to say -4. So what is B? What is A? Now they are independent. I make the change on B. It doesn't change A. So it is no more a view. So if you just do a normal slicing, that's a view. But if you want to get an independent copy, then say np.copy. So it is copied. It's not view. So that's one of the differences from slicing in case of a array and slicing in case of a list. But I'm sure that you're not very interested to know all these properties of array unless I say what is the utility of an array. Why should I do an array? Okay, I have an array which is how many elements? It is a 1, 2, 3, 4, 5, 6, 7 elements. So let's try another array, np.array with 7 elements. Say 3, 2, 1, 2, 3, 4, 5, 6, 7. So another list, BB is made. So A dot size is 7 and BB dot size is also 7. Okay, we are happy. So now the utility of array is AA plus BB. So if there are a list, what will happen? If A is a list, BB is a list, we know what happens in case of list. The plus sign concatenates to a list, to a greater list. We will have a list of 14 elements. But what does it do here? If you can see this is poor man's MATLAB. You can see, I think most there are in this seminar there are many present here who are quite familiar with MATLAB, and you know MATLAB does the same thing. If you have two arrays and if you do a plus sign, it adds them element wise. You get another 7-element list array where the seventh element, this array is created by taking the sum of these two. -3 plus 3 is 0. 2 and 2 is 4, 17 and 1 is 18. So there are element-wise summation, like the way two vectors are added. So, and these things are done in MATLAB. So it's a poor man's MATLAB, therefore. And you know, I mean, we already have some experience of using pirated MATLABs in our home, and in one of the last few years, I mean, maybe last year or the day 2018, we woke up one day and found that all the pirated MATLABs installed in our personal computers are no more working. I mean, you can remember those nightmares. And then what do you do? Particularly Showman knows very well that how the nights were spent at that time when you have half of your thesis work done in MATLAB, and you find that the MATLAB is not working anymore. So my advice is that don't do that. I mean, unless you can, you know that I mean, your institution may have MATLAB. All of my institution also has MATLAB, but I don't have access of running that MATLAB from my home. So there's no other way. Switch over to Python. So this is A plus B. A minus BB also does the same thing, the array-wise, and this is the thing that needs attention. A star BB. This is also an element-wise multiplication. It is not a kind of multiplication that it's not a matrix kind of a multiplication. It's a what do you call element-wise multiplication, right? So every element-wise multiplication. So this star plus, and of course you can have a division also, A by BB. And you see automatically the data type is changed because the first number, it has to get a decimal floating point number. Although the integers A are integers, BB are integers, when you ask for doing the division, it gets that, it finds that it has to generate some numbers which are floating point. It automatically does that. You have a floating point numbers. The D type of the consequent array is changed. But say A is this. Now I want to set A. This is something important. A of say 0, which is -3. I want to set it to say 3.67. Let's see what happens. Sorry. It doesn't take. It doesn't take. So in normal by doing in case of a normal reassignment of the array A array is the entity you are not changing. Its D type is fixed. So if you want to do a kind of reassignment of a particular element, and if it is not matching with the D type that is already there, it will do an approximation. Like 3.67 will go as 3, but D type cannot change. But when we are doing it AA by BB, you are not changing the D type of A, neither the D type of B. The consequent array that will be created, it automatically determines the D type of the consequent new array that is being created. So it creates a new array with a appropriate data type. That's it. So you can do all this thing. And now let me work with a 2-dimensional array. Say A equal to np dot array. 2-dimension, right? So as I said, the prototype of 2-dimensional array is list of a list. So 1, 2, 3, 3, 2, 1, 3, 4, 2. So see, this is a list. This is a list. There are 3 such lists, and 3 lists are enclosed in a great outer list. So it's a list of a list, and ultimately np.array has to be operated on a list. So it's operated on this list, and array is a. Now this is something a.endim. If I say that will be 2-dimensional. Now this is called a 2-dimensional array. Now you can see, in principle, I could have, this is a kind of an array list. I can have repeat this kind of thing. I can have, say, 4 or 5 such lists and enclose it in a greater list and ask A to form an array over that. So it is a list of a list of a list. If I do that, then that will be a 3-dimensional array. I can go on doing this, list of a list of a list of a list. And if I do the array of that, that will be a 4-dimensional. So in principle, in its n-dimensional array would mean that you can go to any dimension, from 1 dimension to any n dimension. Of course, I never used arrays of more than 3 dimensions, but it's quite possible. I mean, theoretically, it is possible. Now, if you have 2-dimensional arrays are more similar to matrices, where these are rows and these are columns. And definitely, if I say just A0, what will happen? It's quite understandable. The first row, I'll get the first row. If I say A1, I'll get the second row. No wonder in that. But if I want to refer to a particular element, say this element, so it is the first. I mean, it should be an element of the A1 and the 0th element of A1. So the best way of one of the way of doing it is this A1 and 0. That will give me 3. But you can do it this way also. Because it's an array, this is also a valid thing. These two things are equivalent. You can see A10 and A 1 bracket 0 bracket, or A10 are the two similar thing. Now, but so usually we call these ones array. Sorry, these are called rows and these are called columns. We know, but because in the array, in-dimensional array in NumPy is equipped for multi-dimension. They have a new and a different nomenclature. The columns, this is called the word, this axis, the column axis is, I mean, 1 2 3 2 4 3. If we proceed in this direction, this is called axis 0. And if we proceed in the horizontal direction, that's called the axis 1. So this is axis 0 and axis 1. These are the names used for NDRA thing. If you have to refer to a particular, do an operation row wise, we have to say 1 along one axis. And if you have to do it in the column wise, we have to say we are doing it in the row axis, 0 axis. Okay. And about the slicing, is this, say I want to, okay, say I want to get the second column out. In case of a list, there is no way you can find out the second column, but here it is. Second column, A colon comma. Second column is actually in a normal English language, but it should be 1 here. You have to specify the index, because first one starts with 0. Sorry, why it is so? My cursor is behaving in a very strong way, in a strange way. See, 2 4 2 2 4. You can see 2 2 4 as. Now, if you are intelligent, you can understand actually what is the syntax of this. Syntax of this is actually A colon, I don't know what happens. A colon M. What happens? Very strangely it is behaving. Let me close it down. I don't know what happened. Let me reboot my computer, okay? So I'm just going out and we'll come back very soon after rebooting my computer.
Uh, Participants, there is a small technical fault. The presentation will start within a minute. Please bear with us. We will start within some minutes, 2-3 minutes. Just wait.
Okay, I'm back. Can you hear me? Can you hear me?
Yes, sir, you're audible.
Yes, sir. No
Okay.
problem. You can come.
Okay, thank you. And you can see the screen, right? Right? Can you? Can you see the screen?
Yes, sir.
Can you see the screen?
Yes, sir. Yes, sir.
Please give me a
Yes,
feedback.
Yes, sir.
Yes, sir.
Yes, sir. Yes,
Okay.
sir.
Okay, thank you. So import in NumPy as NP, and as I was dealing with a two-dimensional array, so np dot array. Sorry,
Sir, sorry to interrupt. Sir, screen is not visible.
is it? Nobody can see my screen.
No, sir.
Yes,
I
sir.
have
No, sir. No, sir.
present is
No,
going
sir.
on.
No, sir.
Huh?
Mm.
What? No, sir. You can't see.
No, no, no.
Sir, it has
So we
been
can see your
minimized
screen.
actually.
Yeah,
Pin the
I'm now
screen
in
actually.
the.
Pin that window.
Yeah. Can you see the screen now?
Yes, sir.
Yes,
Sir, I can.
yes, sir.
Okay.
Yes,
Please
sir.
proceed. So it's a two-dimensional array. Okay. No. There is array is a function. So now, so A is a two-dimensional array. As I was talking about this slicing. So the point is, I told you that if you want to get a column of this, you have to give colon comma 1 will fetch you the second column in the normal English. That is 232. So now if you're intelligent enough, you can see actually the convention is A, and then I would say M colon N and say U colon V is the actual syntax. That would mean that you want to slice from mth row to the nth row and mth column to the uth column to the vth column. Is it clear? But what is the connection between this and this? In this section, I've given a column, but gave default to the to this and this. So it will take from the start to the end of all the rows. And here I'll just mention one column. So it will take give me all the rows of the first column. Here I could instead say for example, what does it mean? I mean that I want from 0 to 1. So 0th row and the first row of the columns starting from 1. That is this column and this column. So these two columns I want, and from the row I want 0 and the first. That is the first row and the second row. So if I do that, see, this will give me 0. 2, 3, sorry. Only 2, why? So this is one. So I want the last row of the no, I don't want the last row. But for the last row, I stop at the last row. So from the beginning, stop at the first row. So -1 row. So this row I don't want. This row I don't want. and I want the first column. So this is 2, 3. 2, 3 will be fetched. That's it. So this is the way of slicing. Slicing basic syntax is this. You remember that this is the basic syntax, that you have to give a colon, and here you should, which column to row to start from, which row to stop at, comma, which column to start at, colon, which column to stop at. That is a very kind of syntax of the slicing. Now the point is, if A is a two-dimensional array like this, and B is another two-dimensional array that we define in P.array, another two-dimensional array, say 2, 3, 2.
স্যার একটু ইন্টারাপ্ট করলাম স্যার, আপনার আরেকটা সেকেন্ডারি স্ক্রিনটা ওটা ভিজিবল হচ্ছে না।
হ্যালো স্যারের স্ক্রিনটা নিচের দিকে আছে, তোমরা একটু নিচের দিকে যাও, নিচের দিকে স্যারের স্ক্রিনটা আছে, ওটাকে ক্লিক করলে দেখতে পাবে, ওটা উপরের দিকে নেই, নিচের দিকে আছে, তো সার্চ করো।
স্যার নিচে
পিন করে নাও,
দেখা যাচ্ছে না।
পিন
করে দাও, হ্যাঁ। তোমাদের যে গ্রুপে যাও, গ্রুপে গিয়ে লাস্টের দিকে চলে যাও, শেষের দিকে দেখো ওর অবস্থায় দুটো স্ক্রিন পাবে।
হচ্ছে না, আমি শেষের দিকেও গেছিলাম, কোনো স্ক্রিনই পাইনি।
তুমি বাকিরা কি দেখতে পাচ্ছ?
হ্যাঁ স্যারের একটা অ্যাকাউন্ট রয়েছে, ওটাই দিয়ে ক্লিক করো, ওটায় গেলে পেয়ে যাবে।
হ্যাঁ স্যার।
তার মানে আমার হ্যাঁ, মানে তুমি কেউ যখন দেখতে পাচ্ছ তখন আমার দিক থেকে কিছু করার নেই, যে দেখতে পাচ্ছ না তাকে পিন করতে হবে।
আউট হয়ে যাও একবার, গ্রুপ থেকে বেরিয়ে যাও। গ্রুপ যদি না পাও তাহলে গ্রুপ থেকে বেরিয়ে গিয়ে আবার ইন করো, তাহলে নিচের দিকে হয়তো পেয়ে যাবে, আছে।
অ্যাকচুয়ালি প্রেজেন্টেশন থাকলে ওটা একদম ফার্স্টে থাকে, তো ওখান থেকে একবারে পিন করে নেওয়াটা সুবিধা হবে
না। এটা তো ওপেনিংটা তো অ্যাকচুয়ালি
আগে ডিসাইড করো, তবে আমি বলছি। আমাকে তোমরা বলবে কখন কন্টিনিউ করব। Can I continue?
Yes, sir.
Yes, sir. You can continue.
Okay. So B is another array. So A is a two-dimensional array, B is a two-dimensional array, and as I said, that is a poor man's MATLAB. So you can just have A plus B, that gives you this, and A star B. Remember, those who are familiar with MATLAB, A star B is not matrix multiplication. It's a element-wise multiplication. So you can see that A is B. A is 1, B is 2, so 1 into 2 is A star B 2. So it's element-wise multiplication, but we know that it's a matrix. So, I mean, if you want to treat it as a matrix, then we want to do a matrix multiplication. If you want to do a matrix multiplication, then the trick would be A dot EOT of B. That does the matrix multiplication. So there's a difference, that if you want to treat these two as two matrices and to get the matrix multiplication, so you have to give A dot B, whereas A star B does the element-wise multiplication. And therefore you can have 2 star A. What does it do? It multiplies 2 into every element of A. If you can do A star 2, that gives you every element is squared. And NP has, I mean, as I told you, that if you want to do with normal Python, for doing mathematics, you have to import math or CMath, right? But the advantage of it is that NP has all that math with itself. So you can just have, for example, np.sqrt. It's a square root, but NP has square root. NP dot square root of A. See, every element is square rooted. So this is called a vectorized operation. Square root is now vectorized. It applies on every element. You can also have np dot sign of A. Every element is sign. So let me go back to my slides and then I can show you this thing. Yeah, you can see there are many mathematical functions like sine, cos, tan, arc sine, arc cos, etc. Everything that you normally get in math, they are available in NP. You just have to say NP dot sine or NP dot cos, so that you can operate sine or cos on every element of it. So that's it. And there are few things that I've missed. I should talk about that. For example, this A. A is a, what is the size of A? A dot size. Be careful that there is no bracket. Size is not a method here. What if it is a method, then it should have a parenthesis after size. It's not a function. It's not a method. It's an information. That A has all this information, the shape information, the size information, etc. So what is a shape? Shape is an information. So you don't need a parenthesis. You just say shape. It's a 3 cross 3. Now you have 9 numbers. You can always reshape it. For example, you can say A dot reshape. Now a 2-dimensional array becomes a 1-dimensional array. It's like a matrix. It has 1 row and 9 columns. Or you can say that it's a 9-1. See, you have 9 rows and 1 columns. So everything that you can do all the reshaping, but you have to remember that by reshaping you cannot change the total size. If you have a shape, original shape of 3 cross 3, then you have 9 elements, and I mean you have to be, that's a restriction. You do all the reshaping, but keeping in mind that the total number of elements is 9. So you can always redistribute it in the ways. And now reshaping, etc. Like A is now this. After reshaping, you have to, of course, A is still not changed because although I gave this command, A is actually not shaped. But if you want to do this, you have to keep it in a different name, like B equal to this. So B is now reshaped array. This. Now, for example, okay, let me try another one. A equal to say another. Okay, A is here. A already I have, and let me take another 2-dimensional array. A more interesting one. NP dot array. Is this right? Now if I write a max of A, np dot max of A, np dot max of A. Here the maximum element, the one which is maximum, is 8, but I can do it this way also. What does it mean? That you have to go through the axis, right? So look at the first axis. 0 axis, 0 means you have to go row wise, like column wise. You have to go vertical. 0 is vertical axis. So vertical axis, when you go along vertical axis, so look at the first column, 2, 1, 3. Which one is the maximum? So it gives me 3. Go to the second axis. which one the second vertical axis? What is the maximum? 6 that is reported here. What is the third maximum in among this 3 to 8? It's 8. So 0 says that you have to look at each column. But you have to go vertically and see at each column what are the maximum. So you report the position of the maximums. Whereas I can give the same thing as 1 horizontally. So that means you go to horizontally. This is the first element is 5. In the next one it is 3. The next one it is 8. See, 3, 5, 8. So you can do all sorts of things with the 0 and maxima along both the axes. Now let me try an example which will exemplify those things. Like okay, not this one. Demo marks MStat. Okay, let me. This is not very interesting. Okay, let me say one. Let me, because I have already. This is, I'm using one more ID. But will you have just a minute? I have a phone call. Let me receive the phone call. সেলিম, এখন আমি কথা বলতে পারবো না, একটু ওয়েবিনারে আছি। No, I can use Spider, but if I have Anaconda, along with Spider, there comes other environments also, like Jupyter. I've started this Jupyter by typing here Jupyter, as you see, Jupyter. That gives me Jupyter, and I click that, and that actually opened Chrome. Chrome, it uses Chrome as a environment, and then from Chrome, I already have a file. Let me yeah. So, I don't know why my computer has become so slow. Stat demo. Okay. This is another environment. Okay. Okay. Let me show you this. Now, say I have a data file containing maximum temperature in Fahrenheit. Can you see this? I think it's visible, right? Give me a feedback. Give me a feedback.
Yes, sir.
Is it visible? Okay. Now let's see. I'm running Python in a new environment called Jupyter. It's something like this Spider, but it's a more easy one. So Jupyter. Here you can write the program, you can run the program, or you can put your comments over there. So I have my topic is file handling by NumPy and rudimentary statistics. So say I have a task of data file. I have a data file which looks like this, and I have this name is sumdata.txt. I have to read this file, and that contains temperature in Fahrenheit of a city on successive days. My task is to read the file, convert the temperature into Celsius, and plot. Okay, let me. There are some already run results which I want to clear, and so that everything is run in front of you. So the right command would be import NumPy as NP, and I would like to plot that. That's later on. For plotting, this is the command that I was talking about. Another module called Matplotlib. Matplotlib is a library which gives you functions for plotting. I will discuss that in a detail later on, but let me show this. The command is import matplotlib.pyplot. That means within my matplotlib there is another submodule called pyplot. I import that and give it a short name PLT. Once again, like NP, PLT is a universally used short name. So I would advise that you also give it a short name PLT, because if you give it PLT, everybody understands that you are actually referring to matplotlib.pyplot. Now, to read the particular file, what you have to do is to give np.loadtxt. That is the function. np.loadtxt, and you have to say where the function is there. Function is in this directory that you have to give this. But remember that once again, this has /users, /orunabho, /download. So that the computer Python doesn't confuse it with the normal escape sequences, I put a R here. That is, I want to say that these are not escape sequences. These are actually part of a, you have to interpret them literally. So that is why you have to give an R over there. So you give this, so you can see it's np.loadtxt given output. So, I think some data.txt is something like this. It's not this one. It's a different file. Okay. I don't know what it is. Okay. So it's a 3-column data, not this one. It's a 3-column data. I added a new column to it. I forgot. So it's a 3-column data. And now, if I give this kind of a statement, it executes the statement and gives me the output. But this the whole thing, this array is not kept in a variable. So let me keep it in a variable. So I repeat this one. I keep it in a variable m. Now, as I know, I can always extract the columns of this. Columns of this I can extract by giving a 0th column I keep it at D, and the first column I keep it at TF. Temperature in Fahrenheit, right? So 0 is kept at D, and the first column is a Fahrenheit temperature. I kept it as TF. Now I have to convert it to centigrade. I know the formula to change Fahrenheit to centigrade is this. Now see the beauty of using Python, NumPy, that I don't have to run loops. I just can write this as an algorithm. I know the formula that if TF is the temperature in Fahrenheit, this is the formula to be used to convert to TC. Just use that. You are using NumPy, so it doesn't look like a code. You actually want to apply this on every element of TF, but just forget about that. You can just write the formula. It gives you TCs, and you plot Ds and TCs. So just do it. See? The function is plotted, and you can see what are the extra qualifier. It tells it that you plot D with TC, and this plus sign tells that you have to say plot the markers with a plus sign. And what are this minus? It tells you that you have to plot this with a dashed line. That's it. You can specify this. Specifies the marker size. Everything is optional. You can omit this one, you can say this. So it plots with the default arguments, default marker size, and default values. You get a plot like this without marker, just line joining. So you can always have those things. Now I want to say this temperature which is in the Fahrenheit. I've converted them to centigrade. I want to create a file where the days and the centigrade temperatures are written. Now this TC is a what is TC? If you want to see what is TC, let's see. Insert a cell above and just write TC and run over here. It gives me TC. What is the shape of TC? Shape of TC is one-dimensional, and therefore just 8 element. I want to write as a row, as a single column. I want to write it as a column. So 8 rows and 1 column. So I just reshaped it. I reshape D as D dot reshape 8 1. That will be 8 column and 1 row. Now, how does it look like then? How does it look like then? I did the same thing with TC also, but let me see how does. So see, D instead of being a horizontal one becomes a vertical one, and the same is about TC. TC becomes a horizontal one. So these two horizontal columns I want to stack parallelly. So this is a column to stack. So D and TC, two horizontal columns, are now stacked together horizontally. So that is it. This D column, D becomes a column vector, TC becomes a column vector. By reshaping, I just stack them together horizontally. So I get something like this, and I have to save that. So just the command is np.saveText and give a name and which matrix you want to, array you want to shift. Just give the name of this. That saves you the data. Okay. And okay, let me run with another program. Say this is the one. Let me see what is demomarks.t. If it is there, it's the PyCause. Let me see what the data is. It's the data file.pycause. No, not this one. This PyCause. Demomarks2. Let me see what it is. Yeah. If you can see plus. Now, this is the data. So you can see that the only problem is that it has the data. This is the numbers, and then it already has some strings. This, say for example, what is this? I wanted to create this as a kind of a tabulation sheet. So these are the names of some students: A, B, C, D, E, F, G. They are the name of the students, and these are the marks obtained in physics, chemistry, mathematics, engineering, and environmental science. Okay. So these are the things. So I want to read the numbers. So let me try this one first. Let me try this one first. Just like the one I did here. Similar thing. np.load text this. Let me run this and see. It gives me error and tells me that it is. The problem is that it could not convert the string to float. There are the strings present. You can see name, ph, ch. These are the strings, and it cannot convert it to a number. So it is giving me an error. So actually, the best way to do it is to skip them. Like put a hash over here, and now the same thing, but I give an extra thing. Skip rows equal to 1. That means in this file you skip one row. This row is skipped. So you won't be reading this file. And use calls. Which columns are to use. Now you see np.arrange. I didn't talk about arrange. What is arrange? Okay, let me try arrange. Okay. Insert a cell above. What is it? np.arrange. np.arrange generates an array. So it's, let's say, 6. Can you see the similarity? np.arrange is something like range, but it is also an array. Range gives you a list, but arrange gives you an array. But it is otherwise similar to range. So you can have starting number like 1 to 6. It will give you start with 1, say 1 to 5, stops at 5. You can give an increment like this one. It gives you with a proper increment, but the best part of it is that it is something more than it gives you a difference is that it gives you an array. Otherwise, it's a range. But the best part of it is that you can have 2 and then 0.2. Range doesn't accept the floating point number. This one accepts floating point number everywhere. So I mean, all the arguments can be float if you want. So that is it. That is the beauty of arrange. So let's come over here. So I give np.arrange A to 6, 1 to 6. That means that I want to use column 1, 2, 3, 4, 5. Look at this one. This is the 0th column. I want to skip. So I want to write 1, 2, 3, 4, 5. These columns I want to read. I have already skipped the first row. So the first row is skipped, and among the columns I want to use three columns. If I don't want the consecutive columns, I can specify an array, like I want this first column and the third column and the fifth column perhaps. I mean, that's also, you just specifying, instead of giving np.arrange, you can just specify 1, 2, 3. That's also possible. So just run this. It didn't give me any error, so it seems that it has worked. Let me verify this, right? That whether I've got it right. So just put M. That will show me the M. I could have. These are the marks. So what is the m.shape? M.shape is 10. So there are 10 students and 5 subjects. All marks are given. Now you see that if I say np.min m, 1, m is the matrix, and what is A1? 1 is along this axis. So this will give me the mean of the number obtained by each student. What is the mean of these numbers? What is the mean of these numbers? What is the mean of these numbers, etc. So I can do this. So just give AVGS. What is the value of AVGS? I want to see. Okay, it's an array. That means 79.4 is the average of these numbers, and this 83.2 is the average of these numbers, etc. So I know at a go what are the averages of each student and what is the standard deviations of each student. But if I am a teacher, say I'm a physics teacher, I want to know what is the average number scored in physics. So I will just give M0. So I want to have the average of these numbers, which are numbers of physics. So that will be something like this. That 68.3 is the average number in physics, and 64.4 is the average in chemistry, etc. So these are simple, and I can skip this Z-score business. This is now, this is interesting that it's a covariance. It gives you the covariance, right? Normally, if you know that if you give covariance, it does covariance of the rows. This row versus this row, this row versus this row, the covariance is done. But if you want to, so it's a covariance between the students. But if I want to do the covariance between the subjects, so I have to say here covariance, row variance equal to false. Normally row variance equal to true. That is, the variances are calculated along the rows. I mean the variance between the rows. But if you say covariance row var equal to false, so actually we'll be talking about the variances of the along the columns. And if you run that, see, these are the variances. Of course, the diagonal elements of these are the variance and in that particular subjects, and the non-diagonal elements are of interest. Say, for example, this is a very high non-diagonal value, 459. It's a value between the column 1 and the column 3. That is physics and mathematics. That says that those who are good in physics are good in mathematics. Those who are bad in physics are bad in mathematics also. So that is something like this. Now, NP also has random numbers. So I can call np.random.randint. That will give me random integers of this 10 means that, okay, let's say. If you want to see the numbers first, so there are 30 numbers are created, and Oh yeah, and in 10 means that the numbers are restricted within 0 to 10. Numbers are restricted within 0 to 10. It can be 0, but it cannot touch 10. It should be less than 10, right? So it is less than 10. It's an open, closed interval from 0, but open in 10. It doesn't touch 10. So it will be restricted between these numbers. I can make it say try. I can make it say 100. Let's see what happens. See, the numbers are changed, and size 30. Size I can vary, and I've plotted them. This is something like this. Now, what is the argmax of x? What is the maximum value? Oh, what is the difference between max and argmax? If I say, that will give you the maximum value that I got here. Maximum value is 97. Look at this. Maximum value is 97. But if I want to know at which position this 97 appears, then I have to say argmax. That will fetch me the value of the maximum. That will fetch me the position of the maximum. That it is in the 7th position. So 0, 1, 2, 3, 4. Actually, in common English language, it is the 8th position. Now, look at this. What it is doing. Can anybody guess what it is doing? Look at this code, portion of the code, and tell me what it is doing. If you want, I want. Somebody has to tell me what this code portion of the code is doing. XA equal to this. I want some answer from you. Can anybody guess?
Is it finding the average?
Sorry?
Is it finding the average?
Average of what? Definitely 3 numbers are added and divided by 3. So it's some sort of average, definitely. But what are the numbers? What are the averages of calculated? Definitely it's an average, but the average of what?
Can you just scroll it upwards so I can see?
Sorry?
If you can just scroll it.
Huh?
If I can see it, the numbers, the table.
I can't hear you.
Sir, if you scroll upwards, then she can see what actually. So she is asking for scroll up.
Or if you like, I can perhaps run it in the Spider, if that helps you. For example, in the Spider, okay, let me try it in the Spider. NP is already there in Spider, so perhaps visibility is better in Spider, right? So I run this in the Spider first. And then run the second command. Is it visible now? Now tell me what it is doing. Those who are from electrical engineering background or something like, I mean, people who are interested in rolling average of the signal, will understand this. You know, if what is this? Look at this one. X is an array and it's a slice of X. What is this? Is colon. This is a default, so it starts with 0, but stop is at -2. So it stops before -2. -2 is -1 is the last one. -2 is last but one. So it stops before last but one. So it's actually a original list, but for the last two elements. But for the last two elements is a list. And what is this? This is the same list, another slice, where it starts from the first, it skips the first element and skips the last element. Skips the first element and the last element. So one element from in the beginning and one element in the end is skipped. So the first element of this is x0, but the first element of this is x1, right? And what is the first element of this? Is x2. So now if they're added, what you get is the first element of x, the 0th element of x, the first element of x, and the second element of x are added together and take average, to take an average. And then what next? It will operate on the second elements of this slices. So that will, I mean, if you can see, it will always take 3 consecutive values of the x and do an average. So this is called a 3-point rolling average. So, you know, sometimes we see that, for example, in COVID cases, we seem to see in the graphs that in the newspaper that every day the number of new cases are plotted in a graph. Then also you get a graph of a 3-point rolling average, where, I mean, in case of a everyday new cases graph, there's a lot more fluctuation, and if you want to smoothen it out, you want a 3-day rolling average. So what you want to do the 3-day rolling average, this will be the technique. Want to do a 7-day rolling average, you have to extend it to 7. That's it. Okay. So these are the things very easily done in NumPy. The special array generators, I've already talked about arrange. Zeros mn generates an array with all zeros of m cross n dimension, m rows and n columns. Once you can understand that it fills everything with 1. Reshape, zeros like, say I have created a dot shape, that is originally a array. Arrange 8 and 5, that give me arranged 8 and 5 give me a array which is a one-dimensional array of 0.5. So it is actually starts with 1, increases with 0.5 and stops before 10. So how many elements are there? I give the command print a dot shape and give me the output 18, and then I reshaped it to 663. So I've reshaped it to a matrix which has 6 rows and 3 columns. And then this is I print B, that printed. And then I created a C which is zeros like B. When I say zeros like B, I don't have to specify the number of rows or the number of columns. It takes the number of columns and the number of rows and the number of data type from this B and creates a 0. And so these are the other possibilities of generating arrays like empty. By empty you can empty like. I is the identity matrix. Ones I've already talked about, zeros talked about, etc. So there are many ways of generating predefined arrays. These things are already discussed. And linear algebra. Okay. Linear algebra is that Python has a huge linear algebra library. For example, this is my matrix A equal 2, 8 minus 1, 8 2 minus 1, minus 1, 2 minus 1. I want to print the matrix. This is the matrix. So I want to take the transpose of this matrix. This is just A dot T. A dot T will give me the transpose of this matrix. And I want to calculate the determinant of this matrix. Is np.lineage. NP has a submodule called lineage, and within that lineage, it has a function called det. So call np.linals.det. That will give you the determinant of this matrix. If you want to calculate the inverse of this matrix, is np.linals.inf A. That will give you the inverse of the matrix. And eigenvalues. E, V np.linals.ig A will E will give you the eigenvalues and V will give you the eigenvectors. So see, these are the eigenvalues. 9.9 minus 6.6 minus 1.29 are the eigenvalues, and these are the eigenvectors. You have to understand that eigenvectors are placed as a matrix where the first column is a normalized eigenvector corresponding to the eigenvalue 9.9, and the second column is a normalized eigenvector corresponding to the eigenvalue minus 6.62, and the third column is the corresponding eigenvector, normalized eigenvector corresponding to the eigenvalue minus 1.29. Okay. And we have to solve an equation like Ax equal to B. Ax equal to B, where A is an n cross n matrix and B is a vector, right? So I give this one. In this case, this is 3112 is my A, and so this is the A matrix, and B is 98. So actually, I want to solve this equation with this matrix times x equal to 98. So this is the equation. I want a solution. Solution is just simple. X equal to np.linals.solve, and you have to give the matrix A and the vector B, and that gives you the solution X. If you don't want to look that way, if you want to get as a column vector, so just give reshape. That will give you a column vector. Okay. And NP also has many random number generators like rand, random, etc. You can play with them. And as I've already told about the things like NP, with NP you can have mean, and these things I can forget about. Now I come to the next topic, that is matplotlib. Yeah, I have something like more than an hour. Okay, I can be a bit more. Okay, let's go to matplotlib. Matplotlib is a plotting. Okay, I can write a new program, new file. Okay, let's import NumPy. It is always easy to deal with NumPy as NP. Import, as I said, matplotlib. Once again, let me tell you, matplotlib is not part of the basic Python. You have to get it either through Python XY or Anaconda. But if you cannot install any of them, there are other ways of doing it that we can discuss in the WhatsApp group if needed. I think the need will not be that much. Import matplotlib. The word matplotlib tells you that it's a plotting library. The mat. What does this mat stand for? Mat says that the commands are taken like MATLAB. So those who are accustomed with MATLAB plotting can skip this portion of the talk, because it's just like matplotlib as PLK. So those who are familiar with MATLAB plotting will find them very easy. Now, let me create first another array by using linspace. Linspace takes 3 arguments. Starting, I say 0, and say I'll go to up to 3 pi, 4 pi, 4 star np.pi. NP has a predefined pi, and then I want to create in between. The starting number is 0 and the ending number is 4 pi, and in between I want to create, say, 200 numbers. So there will be total 200 numbers. That will start from 0 and linearly increase to 4 pi. That's it. So that's an array, and I want to make the sign of everyone. So that will be y equal to np.sign of x. and let me call this y1, and let y2 be equal to np dot cos of x. So one is sin x, one is cos x. Then I have to plot. Plotting is plt dot plot x comma y. That will give me the plot. Okay, save as any name. Plot 1. Run this. Y is not defined. Yeah, definitely. I have y1 and y2. Y is not defined. If you want to see, the graph of sin x, right? So this is the thing. Now, as I've told you that you can play with this, like you can play with the markers. You can say that you don't want one. You can just simply say this. Let me see what will happen. So these are plotted with small circles, right? And not the lines. And the difference is not very observable because you have too many numbers. So reduce the numbers so you can see them well. See, you've just skipped the line. You've just plotted the numbers with small circle, and you can play with marker size even. Marker size equal to say 1. Let's see what happens. They're plotted but almost not visible. I mean, they're very small. So let's make them 3. Barely visible. So you can see these are the ways to do it. So, and you can have another symbols like say a hat. Give hat. Let's see what happens. And if you can see the effect, see, instead of circles, now I have triangles. And the point is, how do I know what are these things? The point is just plot type plot. Sorry, help plt dot plot. This will give you huge amount of help. So please beware of this. This will give you a huge amount of help. Now the point is, yeah, that gives you the description of the markers, that so many options are there for the markers. So you know, if you want this kind of a marker, what you have to do, O is circle marker, and the hat that I used is triangle up markers. So there's a list. You don't have to memorize, you just see the help PLT, that will give you the available markers, that will give you the available line shapes. There's one dash will give you solid line, dash will give you dash line, etc. And of course, you can play with the colors, like here I can say blue is already there, so just give R. So red circle. So this is here where you can say here you can give dash also. So that will look like this. Okay. So these are the things, and you can play with. This is only a y1. You may want to have 2 graphs superposed into it. So x, y2, and that should be plotted with, say, let's see this. Give it a different color, and what? Okay. See, these 2 things are marker is changed, line style is changed, and 2 graphs are superimposed. So you can go on having many plots superposed. And next thing that will be interested in is plot.legend. legend. First one was sine and the second one is cos, I believe. So just give that. Can you see? Sine and cos. And it is placed over here, because if you don't give the location of the legend, it will find out the best possible position. So my suggestion is that don't try to specify the location of the legend, because MATLAB Python does it very smartly. It finds out a suitable position to place the legend, but you can manually also decide the position. For that, please read the help. That will give you the manually where to place your location of the legend. And then, of course, the x-axis, plt.x level. Is, say this is angle in radian. Angle in radian comes over here. You can also play with the size of the size is, say, let's make it 20. Say, yeah, it's bigger, and then you can also plot plt.y level. Trigonometric functions, whatever functions, trigonometric functions. If you do that, run this trigonometric functions. You can also always play with this. The interesting part is that, I don't know if some of you know LaTeX. I mean, this Matplotlib is equipped with LaTeX, so you can say R. If some of you know a LaTeX command, I can show you. $. Now, if some of you are familiar with this, you know this is a LaTeX command. This one is a LaTeX command. Enclosed between $2 is a LaTeX mathematical command. And once again, because of this, I've given R so that these are not confused with the escape sequences. So if I do that, let's see what happens. Can you see sine theta and cos theta? See the thetas over there. So you can write Greek characters also with this LaTeX commands. So like mu, theta, and all the Greek characters you can write with it. And now the title, of course, plt.title is some plot. Okay, so these are the things that we could do with simple plots. And now my slides contains more complicated plots that this is a simple plot. I've read the function with. Now you can understand this. I have a data file which looks like this. I have loaded this with command lp.loadText, and I sliced the V matrix, the 0th column and the first column as x and y. I plotted that. It's very simple. And these are also understandable. XY plots x and y using default line style and color with this BO. B for blue, O is for circle. And if I say just one array, if I give one list or one array, what it does, it plots along with x-axis becomes the index number of the arrays, and the y-axis is the values of the corresponding array. And this R plus is something the same, but it is with red color and plus symbols. These are the description of the markers available. These are these we have already discussed. And this is something which I can skip. If this there in the slide, you can always see how I plotted the Lissajous figure, and this is already I've discussed. This is something that if you consult the slide, that tells you how to create two axes with two different values. So these axes is 0 to 10, this axis with 0 to 1. How do you create that? All these details, and this is important. That sometimes when you do experiments, you have x and y as two values, but also with every y value associated with some error values. So your 2.5 is a value which is associated with a plus minus 0.5. This 8.3 is associated with plus minus 1.5, and this 9.3 is associated with plus minus 1.9, and you want to show that in the graph. So instead of plt.plot, all you have to say is plt.error bar, and give the x, y, and the error. That gives you the plot. And this is the bar diagram. Bar diagram, forget about everything, that I have ultimately some x values and the y values. Instead of plot, I want to plot it with a as a bar. So the command is plt.bar. I think I have a bar plot here. Hplot, no, this was not the one. What is dplot? Dplot is the bar diagram. Look at this first. Let me run this. Yeah, it gives me the bar plot. See, I have x, y, and r. E is not used here. I think I can forget about E. So x and y, these are the x is the x-axis, y is the y-axis, and I've specified the color as red. Age color, you can see the age of these bars with K. K stands for black, and the line width of this ages as 5. So these are the things that I can specify, and I can also specify the tick positions. The range of 0 to 2, the 0, 10 to that tells me that it will give me a and because I've given this list over here, it will give me a list which starts from 0 and increment by 2. So 0, 2, 4, etc. No, but it doesn't. Y ticks, yeah, y ticks is this. If plt.y ticks is A, so y along the y-axis, the ticks will be 0, 2, 4, etc. See, 0, 2, 4, etc. Those are the things that I specified. Instead of, I could specify the x ticks also. That is one of the things. That this is with the bar. And these are the things that you can see now. The best part of it. This is something that I, being a student of physics, I enjoy most. It's a histogram. It's a histogram. For example, let me try with this. NP is already there, so let me generate a random number. NP dot random. Random gives you a number between 0 to 1, and I give, say, sorry. You can see that evidently there is a mistake. There should not be a comma over here. So X is what does it mean? That so many numbers. There is 10,000 numbers are created in X. Let's see what is the size of X? Size of X is 10,000. So say 10,000 numbers are created. I don't see the 10,000 numbers. I can plot these 10,000 numbers if you write plt.plot plot X. That will show me the 10,000 numbers, how they are sequenced. See, if you can see, they're fluctuating between 0 to 1 randomly. So there is no, it's almost evenly distributed. So I want a histogram of this. So just simply type HIST of X. That will give you the histogram. Oh, sorry, it's not HIST, NP dot, PLT dot H of X. This gives you the histogram. Almost nothing is visible because it's so uniform that almost so this gives you that okay. Let me first decrease the numbers so that the histogram will be a bit more visible. Let me try just 200 numbers and all this. Now you can see 2,000 numbers. This is a histogram. Histogram starts with 0, ends with n. By default, it creates 10 bins. It divides the interval into 10 and creates the histogram. And I can specify the number of bins by saying that instead of 10, I just want, say, 20. So, gives me 20 divisions. Okay. So, and I can change this. For example, as you know, the students of mathematics may know that if I have a random number and just X is my random number, but if I say Y equal to X square, that's also a random number, but it's not even a uniform random number. Let's see the histogram of Y. Let's see the histogram of Y with the default 10 values. Completely different. This is something that we learn in mathematics, that if you have a random number and if you do a transformation like x square, 1 by x, whatever you do, you get a different random distribution. I mean, it still becomes a random number, but the distribution function changes. So it doesn't remain uniform. And that is how we create an exponential variate from a uniform variate, or we create a normal variate from a uniform variate by giving a proper transformation. So the point is histogram is there, and that is very useful for students of mathematics and students of physics, and multiple plots. This is something I'll show you. But let me see what is there. Before that, this is dplot is done. This is pyplot. This is easy, nothing to nothing very important. That say these are my I did some sort of a survey of the profession of a particular area, and I find that there are 50.4% farmers, potters are there in 24.6%, fishermen are there in the 10%, and the other 15% are the laborers. So I want them to be first. I want them to be plotted in a pie plot. So my command would be plt.py. I want to, these are the numbers which are m contains my numbers which I want to plot them in a pie plot, and each labels. These are the labels of each division. The labels are kept in a array like P, and I want to specify the colors of this each section. That is how I define the black, magenta, cyan, and yellow to be the colors of each section. That is my choice. I could skip this one. Everything that I label equal to P. These things are, as you know, these are called keywords argument, and you can always skip all the keywords arguments. The whole thing starts, if the only essential thing here is the M. the numbers. This positional argument is the only essential argument, and all the keywords arguments are free and interchangeable. You can position it here and there because you will just explicitly saying the keyword what you are specifying at. So all the keywords arguments are optional. You can give them or you can skip them. Okay, and this is auto percentage that tells you that in which format you have to use these percentages, and start angle. I'll show you this do this very. So let's just do it. See the pie plot. See the pie plot? And this is the pie plot. And start angle. Let's play with the start angle. Start angle is minus 45 degree. Just look at this. Where the farmer is placed. The angle is at 45 degree, right? Now make it plus 45 degree. Let's see what happens. So 0 is the 12 o'clock position, and plus 45 degree will go anti-clockwise 45 degree. If you say 90 degree, starting from the 12 o'clock position, if you give 90 degree, you will go to anti-clockwise movement, and you can see the way the percentages are reported. That is given by in this position. I give those who are familiar with C formatting. It tells me that the percentage has to be reported in a floating point decimal. 2.1 says that there should be at least one after decimal point. If I do this like 2.2, see the effect. There are 2 zeros. There will be 2 after decimal points, or better, because I know here okay. So these are the things, and colors. You can always understand that I can play with the colors, like the farmer color, which is black. I can make it red if I like. It's red. So this is about pie plot. This is something different. Plot one I've already talked about. So what are the things that was necessary? Subplots. Yeah, I was trying to play with the subplots. Okay, let's do a subplot. For example, like this. By this sine and cos, these are, let me run this function. This function gives me 2 plots in a superfluous plot. But I may want that one graph. I may want that there will be 2 subplots. How to create subplots? To create subplots, you have to write here. You have to create like let me see. Why did I forget? Let me just see the syntax, huh? Just happens that momentarily you forget the plt.figure. Yeah, that's it. plt.figure. Okay, so you give plt.figure, and plus just give plt.figure first, and then you have to say plt.subplot 1 to 1, and here 1 to 1 is this, and forget about these things now, legend, etc. For that matter. These are PLT dot subplot 1 to 2 PLT dot plot x y2. Let's see the effect of this. Then I'll explain what I'm doing. Can you see? I've created two subplots. Two subplots I've created. Okay. Now, these are the new things that I've created. PLT.figure. That tells me that a new figure is created where I can specify the size of the canvas. For example, I can say that fig size equal to say 12, 6. Let's see what happens. Just play with this. 12,6 would mean that this is 12 and this is 6. So if I say 12.12, that will give me this. This is also 12, this is also 12. And the effect is more visible over this window. See, this is 12,12. And if I say, so this is 12, this is also 12. So if I want this to be 6, 12, that will be something like this. This is bad. So rather keep this 12 and keep this one 6. That will look better. Yeah, that looks better. So you can see what it is. The first one tells me the width, and the second one tells me the length of the canvas. Okay. Okay. So then what is this? It is 1 to 1. That tells me that actually I'm trying to play with a graph matrix of plots, right? And 1, 2 means that I'll have a matrix which has 1 row and 2 columns. 1 row and 2 columns. That is 1, 2 is my dimension of the plot matrix that I want to create. So, and last one tells me that among the 1, 2 matrix, I'm talking about the first one. And this one tells me that among the 1, 2 matrix, I'm talking about the second one. Okay. Now let's play with this. Let's 2, 2 matrix. That I'll be having 2 columns and 2 rows. So these are the 2 things. Then I have 2 more plots. Plot PLT dot subplot 2 to 3, where I will play with, say, I'll play with, say, PLT dot plot x and y1 square. And PLT dot subplot 2 to 4, which tells me, sorry, PLT, PLT. And this is PLT dot plot, say, x and y2, y2 star y1, say, anything, any big thing. So now run this. Why this is blank? 2 to 1, 2 to 2. So this is wrong. This is 2 2. Now you can understand that we are talking about this first 2 2 tells me that I'm talking about a 2 by 2. Sorry. 2 by 2 graph matrix, plot matrix, and the last one says that among the 2 2 plot matrix, I'm referring to the first one, and referring to the second one, referring to the third one, referring to the fourth one. So 4 plots are there in the subplot window. That's done. So this is some sort of thing, the same thing. And 3D surface plot, etc. I'm skipping because I don't think these are important now. You can all, I mean, there's nothing to explain. You just see what the format is, and you can run the program. And important thing is that but I think something would be interesting if I run this program. Something I want to show you. Let's see. I can do it. I hope that there is no print. Although this is written in Python 2, I hope it will work in Python 3 also. But before running this, I run an extra command, star matplotlib. Say the matplotlib will be run backend. Okay. Oh, whenever you copy from slide, beware that these quotation signs are changed. It says that it is already running in the backend. Can I see? Yeah, the extra window is created. It's a three-dimensional plot of a line plot. Okay. Now the interesting thing about this is that you can rotate this. You can have all sorts of views of this three-dimensional plot, right? So for that, remember that you have to give the extra command. Extra command is star matplotlib. But whenever you give star matplotlib, henceforth all the plots will be in the backend. So better if you want to give it go back to the original plot system, just remove this thing. Everything is removed, so you are back to the normalcy. So okay, so so far so good about. I don't want to go to the details of plotting that. You can find out. I mean, there's nothing to explain. I mean, these are the syntaxes that can be copied from my slide. And this is a polar plot. I don't think you need polar plot much. And this is very important that if you want to design your plot in various other ways, those are not discussed in my slide, but please refer to this link that has huge examples of different kinds of plot, and I'm sure that you will find out your kind of plot and the corresponding code how to do that. So use this link. Now, the last topic which I want to discuss, and I think I have enough time. I have at least 30 minutes with me before I hand it over to Showman. Okay. This is the last thing. I can be a bit slower. It's about SciPy. SciPy is another very useful module of Python. It is about scientific computation. See, those who are familiar with numeric calculations, you know that there are many routines by which you do numeric integration, differential equation, interpolation, Fourier transform, all sorts of things. And there's a huge library of doing all sorts of things in SciPy. So if you open the SciPy, you find that SciPy tutorial, if you open, you find that even the SciPy is a so huge thing that SciPy is actually divided into sub-modules. For example, if you want to do it, if you want to see the integration and the functions related to integration, you have to look at scipy.integrate. And there are many ways of optimization. If you want to look at them, you have to go to scipy.optimize. So this way you have to proceed. And the tutorial is very lucid. I mean, the best thing, I could have simply stop here and advise you to go to the tutorial that will give the explicit way of doing such things. But I did give you some examples how to use the tutorial. For example, if you look at integration, you find that even in integration there are various routines, and the integration can be done in two different ways. For example, there are two different situations when I want to do numeric integration. For example, I know a function sine. I want to integrate the function sine x for x equal to say 0 to pi. Here I know a function in the closed form, and I know the limits from which to which I want to do integration. So for this kind of a problem, you have a huge set of alternative functions. One is quad, which is normally routinely used, which is a very strong, very good routine. I mean, by default, we all use quad, and this is double quad for double integration. So say, for example, you have to integrate over an area, so the surface integral kind of a thing. So this double quad. If you have to do a volume integral kind of a thing, you use triple quad, etc. So and there is another situation, and say, for example, you are getting the spectroscopic signal from some element. So you know that at each frequency what is the kind of emission. So you have a graph consisting of some points that gives you that is your data, and you want to calculate the area under the curve. So you have some experimental values of, so you don't know what function does it represent. You just have some sampled data that can be plotted as a graph, and you can see visibly there are two peaks in the graph, and you want to calculate the area under each curve. So these are the called that you are integrating over sample data, and there are of course a few more examples, routines that can deal with sample data. So there are two different kinds of integration with closed form function and integration with sample data. So there are many example routines for that. So let me try a thing like this integration. Those who are familiar with mathematics, you know that this integration cannot be done unless, I mean, theoretically with pen and paper, you cannot do this integration unless you have value of x equal to infinity. From x equal to minus infinity to plus infinity, e to the power minus y squared dy 1 by root pi, that integration can always be done. But instead of infinity, if I say 1, you cannot do it with your pen and paper. You have to do it with numerical integration only. Now, how do I do that? I use, first of all, import scipy.integrate. See the same thing. Import scipy.integrate as SI. I give a short name SI. Okay. And then when I used it, I used SI.quad. SI.quad. Quad is the function that I'll be using, and that takes 3 arguments. The first argument is the name of a function. So I've defined a function ER. See, this is my ER function. ERx, which is equal to 1 by this function, 1 by square root of pi, this. Although this is not a very good one because I've used square root from math. I could have used NumPy also, but this is not used. NumPy is not used in particular example. So I use this pi and exponential from math. I've imported them. So I've defined this ER function. So ER is this, and the limits is 1, so minus 1 to plus 1. I want to do an integration, and this integration is done. So if you and the result is stored in I. So if you just print I, you find there are 2 numbers in a tuple. 2 numbers in a tuple. The first number tells you the value of the integration, and the second number tells you the error in doing this integration, which is 10 to the power minus 15, which is reasonably well. So finally, if you want to know the value of the integration, all you have to do is to print I0. But remember, this one also is developed in Python 2, so the brackets are missing. So when you will be running this kind of a program, you should give brackets. So print I0 will give you exactly the value of the integration. This integration you could not do with your pen and paper. So this is another example. This is simply I varied the value of x from different values and plotted the value of the integration as a function of x. So this can be understood. I mean, doesn't need any explanation. And this is another interesting thing, where I use the numeric the integration with the closed form and integration with the sample data simultaneously. I did both the thing. So my function is here, this function. What is this function? This function are defined through lambda. So lambda x, can you see lambda x np sine. So it is actually function is x into sine 10x. X into sine 10x. This is the function I've defined through a lambda function. I could have defined it using def. Just for the heck of it, I defined it with a lambda function and called that function sine 10. Okay. Now I want to plot this graph. So from linspace, I've used 0 to np dot pi and 100 at point. I just use the sine 10 function on x. So for each of the points, sine 10 is calculated and kept in y, and I plotted x and y. That gives me this graph. So you see, it's a very fluctuating kind of a graph. And okay, it's a fluctuating kind of a graph. Now I want to see the effect of integration by Simpson one-third rule that students of mathematics are well aware of, and the Gaussian quadrature, both with only 20-point data. So I again sample my x only 0 to 2 pi. Here it was 100 points. Now I created only 10 points. So now the y contains only 10 sample points from this graph, and I used Simpson one-third integration that gives me the value. And then I use the same thing with fixed quad. Fixed quad is Gaussian quadrature, where I use the same thing, sine 10 function from 0 to pi, and use n equal to 20. That means that I want fixed point quadrature, Gaussian quadrature with 20 points. So this is a 20-point Simpson rule, and this is a 20-point Gaussian quadrature. And I look at the results, and you can see the result are these two things. And this integration, by the way, is doable numerical with pen and paper. And if you do this integration, its value is minus pi by 10. So that will be its value is closer to this, and this is wrong. So you can see that when you have a very fluctuating kind of thing, your Simpson one-third rule is not a good integrator. It's better for the same sample size you use Gaussian quadrature. That gives you much better size. But the problem is, in order to do a Gaussian quadrature, you have to know exactly the closed form formula. But only if you're restricted with sample data, you don't have the choice of going to Gaussian quadrature. You have to go to Simpson one-third rule. I mean, anything like Simpson one-third rule. Okay. Another example of integration that doesn't need any explanation. You can do it yourself. And this is an example of a double integration. I am not explaining it. The slide will be self-explanatory. This is a root searching. This is interesting. That is an example of a root searching, right? Root searching, you know that if you have a function, you want to know what are the values of x at which this function equal to 0. Now, in this particular example, I've took a Legendre polynomial of order 5. Just to exemplify that SciPy is well equipped, you just have to call the corresponding thing. And that Legendre polynomial is there in SciPy.special. Special is the resources of the special functions. So Legendre polynomial is a special kind of a function which is present in the module called special. So I import SciPy.special as SS, and from SS I get a function is eval Legendre. It will give me the Legendre function, and this is the 5 will tell me the 5th order Legendre function. Okay. Okay. So these two things, x is this, -1 to +1, 300 points, and 5th order Legendre polynomial, I just plotted it. See the graph. This is the graph, and that it is a 5th order polynomial can be understood by looking at the number of roots. You can see that there are this is one root, 0. This is 0 axis. So this is one root, another root, 1, 2, 3, 4, 5. There are 5 roots, so it must be 5th order Legendre polynomial. I mean, at least the order of the polynomial is 5, that I can see. Okay, now do this root searching, I use the famous bisection. Bisection, some of you may be familiar with. I use the bisection formula, and that is present in Optimize. SciPy.optimize has a resources for optimization. From there's a function called bisect. So I called bisect, and that calls for a function. I defined a function, and then the limits of x within which you have to find the root. Because I am searching for this root which is present near 0.5, so I give two values which are possibly bracketing the roots. I give 0.4 and 0.6, and the near 0.5, the root I got is 0.5384. So that's how you do root searching, and now you can explore for other functions, similar functions in SciPy. This is very interesting. That how do we solve differential equation? How do we solve differential equation? For example, I want to solve this differential equation. There's evidently a mistake in the. Okay, let me correct this. Dx dt equal to minus kx is my equation, and at x equal to 0, at t equal to 0, x equal to 10 is my initial condition. And I want to integrate the graph, integrate the solution from t equal to 0 to t equal to 3. And the value of k, because you will be doing a numeric integration, you cannot have the k, undefined k or something. You have to specify a value of k. So for example, in this case, I've given the value k equal to 2. So this is my problem. I have to solve this equation, dx dt equal to minus kx, and this is my initial condition, and I want to integrate from t equal to 0 to 3, and the value of k is 1. Now, to do the differential equation solving the differential equation, the corresponding function, there are many. The most commonly one equation to solve ordinary differential equation is the ODE. ODE is the one that we commonly use. ODE is ordinary differential equation integration. So ODEINT, and it is there in SciPy.integrate. So from SciPy.integrate, I import ODEINT. Now, that gives me a more relevant question, that it appears that I am a know-it-all person. I exactly know where to find what is the name of the function and where it is present. How I have become a know-it-all person? It's just a trick. Type in Google Python SciPy ordinary differential equation. Just type that in Google. Google will tell you that where to find it. What is the name of the function and where to find it. So I'm not a know-it-all person. I just use Google. So ask Google. So if you want to do, after listening to my lecture, if you want to do something with Python, forget everything that I told you. The most important thing that you have to remember, that ask Google. Ask Google. Google will tell you something, and ask with the explicit how to do this with Python. Google will give you the solution. There are many solutions. Okay, so most of the things that I'm telling you, I've learned through Google. So the thing is, therefore, from SciPy.integrate, so there is a function called ODE that I'm importing, and then I'm importing NumPy, that is my usual thing, and I'll be plotting, so matplot. And then k equal to 10, and then I defined a function called tk. Now this is important. Which is important, that if you want to solve a differential equation, you have to define a function, and what is very important is the order of the variables in the function. In this differential equation, x is your dependent variable and t is your independent variable. And here, when you write the function with the differential equation function, you always have to specify the dependent variable first and the independent variable later. So this is the order that you have to remember. You cannot play with that. First the dependent variable, then the independent variable. Okay, then a colon, of course. So that is what I said, xt in this order. You should remember, you shouldn't play with the order. Now, return, what do we have to do? You have to define the right-hand side of the differential equation. Right-hand side is just minus kx. So just you write minus kx. Now you see another important thing, that my function decay does not depend on t at all. But still you have to place it here. Even if it doesn't have any time, it doesn't depend on time explicitly, but you have to place it here. It could be that the right-hand side is a function of time only. There is no x. But still you have to give xt. This is something you cannot play with. X, you have to place dependent variable, comma, independent variable, and while you are defining the right-hand side, that can be a function of the dependent variable only, that can be function of the independent variable only, that can be a function of both, but doesn't matter. The syntax is this. Now here I see that np.linspace 0300. Here I see I specify that you have to integrate from 0 to 3, and there should be 100 intermediate points. And yeah, and then now this is the function. ODEINT is already imported, so just I say ODEINT. Decay is my function which has to be integrated. And what is this 10? 10 is the initial value. So the syntax is that you name the function that you have to integrate. In this case, it is decay. Then the initial value of x. Then the time array. That time has to be something like array, which should contain the initial the time points where you have to integrate. So the syntax is the function name, comma, the initial condition, comma, the time. So, and for the time, for the time being, you can neglect this PLT RC param, etc. You look at this PLT.plot t solve t get solution is t with a solution, it gives you the graph. And other things are just the decoration of the curve. You can see I've used LaTeX kind of a statement to make this kind. This looks like this. This is a mathematical expression. You cannot type it as it is unless you used LaTeX over there. You have to learn a little bit of LaTeX to see how I have specified this. But this can be neglected for the time being. If you are not interested, you just forget about this. So basic thing is this. So the basic things are mentioned in red. Now, second order partial differential equation. So this is d2x dt2 equal to minus omega square x. The point is, not only Python, there is actually no numerical method which solves specifically second order differential equation. Of course, there are a few. I mean, I withdraw my statements, but I mean, most of the common differential equation, numerical differential equation solvers are specific to first order differential equation. So all you have to do is to divide this second order differential equation into two first order differential equation. Like this can be brought down as dx dt equal to v and dv dt equal to minus x omega square x. So instead of solving the second order differential equation, I here propose to solve two first order differential equation. One is dx dt equal to v and this dv dt equal to minus omega square x. So I have two variables, x and v. I have two variables. So second order differential equation is actually mapped to two first order differential equation having two dependent variable x and v. But my solver doesn't allow me to, apparently doesn't allow me to play with two dependent variables. The syntax that I told you plays with one single variable x and t. Here also it is x and t. But these things are like the old ones. Now, problem is the Python doesn't tell you that this x has to be a single scalar variable. You can always, instead of sorry, any question? So Python doesn't tell you. I'm hearing a noise. Is there any question? Is there any question?
No, sir. No.
Okay. Now Python doesn't tell me that. Python tells me that you have to specify the name of your dependent variable. But I can always do a trick. It doesn't tell me that dependent variable has to be a scalar. It can be an array. It can be an array, right? So by x and v are two independent variable, I can imagine that these are packed into an array, and capital X is the name of my packed array variable. So I place that here. So while I'm writing xv, I keep in mind that by capital X, I am actually referring to a packing of x and v. Two variables are packed into a single variable. So within the function, I just unpack them. And this is unpacking, So this first component is x and the second component is v. Now I'm in the common mathematical domain. So I define my right-hand side. The first equation dx dt equal to v. So first right-hand side is v, and the second right-hand side is minus omega square x. Right? Everything omega is defined. So these are the two right-hand sides. Those are created. I pack them again. D and m. So I pretend that as if I'm obeying the rule that I've learned here, that I have pretend that it's almost a single variable. It creates one, it takes one single dependent variable and returns one. I'm behaving as if I'm obeying to the rule. But what I'm doing, actually, while giving input, I'm packing these two variables together, and while giving the return, I'm packing them together. So actually, I'm actually dealing with two different equations. So now T0, but I define the array over T. Array over T is I defined in a 2 pi by omega. Omega is my time period. So 2 pi by omega is my omega is my frequency, and 2 pi by omega is my time period. So I wanted to integrate over n is n defined here, n10. So 10 time periods. I want to integrate over 10 time periods, and there should be 500 numbers in between. Okay. And then, see, this is interesting, that I have to specify the initial value. Look at this. 10 was my initial value. So t is no problem. T is a similar. But the initial value I have to specify. This is ordained, that calls for a function f is defined, that calls for an initial value. Initial value I've given x naught. There is no binding that your initial value has to be a scalar. It can also be a list or an array. So this is my list. So that actually, what do I mean by that? At x equal to 0, at t equal to 0, x is 0 and v is 1. Your initial position is 0, initial velocity is 1. So these are the initial conditions that I specify. Then I ask it to solve, and the solve is created. And now can you imagine what we'll have in solve? Where the difference between these and the other is a single variable thing. Solve contains all my solutions. And here is a two variable thing. Solve therefore contains both the solutions as two columns. The first column is my x and the second column is my v. So if I want to plot, for example, look at this. Look at the last line. Plt.plot t sol column 0. So I want the 0th column of sol to be 0th column of sol contains the x values. So I plot it as a function of time. I get this curve. And something called phase space, which is a plot of x versus v, that is sol 0 versus sol 1. I plot, I get this one. This is called a phase plot. So that is how I can solve the second order differential equation. And if I can jump from 1 to 2, I can now have a freedom of solving n simultaneous equation. All I have to do, I have to split them into n simultaneous coupled equation, and this is the trick. So, and this is something that I can, for the time being, change. Now, this is something interesting. It may, okay, let me go here. This is something I think at the end of my talk. Yeah, A50. some of you may be interested in the FFT. FFT is the first Fourier transform. The Python does many other things, but SciPy has another module of fast Fourier transform. I'll show you some example. For example, I have now see this one. This one is I've created an X from 0 to 20 pi. 0 to 20 pi. I have created n sample is how much is this? 100,000. 100,000 data points. I've taken samples from 0 to 20 pi, and you see I've used linspace, but in a different mode. This is my start. This is my end. This is my number of samples. And what is this? Rate step equal to true. That tells me that if I start with 0 and if I end at 20 pi and if I have in between n samples, what is my dx value? What is the difference between two successive points? That I can also return by simply specifying rate step equal to true. That will return me that. So the output will contain this, x will contain the array and dx will be the value of the dx, the difference between two successive points. So why it is necessary? Because if I want to calculate the Fourier transform to get the x-axis leveling, I have to know this dx. So that is what I do. And then this is my signal. So let's first make a simple signal, not this one. Make a simple signal like this one is 3x. Okay, so I have a signal which has two frequencies, sin x frequency 1, circular frequency 1, and sin 3x, which is a circular frequency 3. Okay, so I mix I have a signal which composed of two frequencies 1 and 3, and y is actually a signal composed of these two 3. I plot x and y, and I'll plot x and y, and then oh yeah, this is something interesting that can you see what it is? It is 0 to minus 1000, and this is 1000 colon 0. That means that this array is an array which is from 0 it starts and ends at before 1000 points of the array, and this one starts at 1000 points and ends at n. So these two arrays are of equal size, but the difference between these two is the first element of this is the 0th element, whereas first element of this of the second is the 1000th element, and this is the second element versus 101th element. So this is something that we normally plot if you want to see whether there is a periodicity in the signal. If there is a periodicity in the signal, this kind of a plot will show you explicitly, whereas there is a periodicity. I can show you with examples. And then I do the FFT. This is the trick of FFT. SFFT, what is? I know that there is a FFT pack in SciPy. I give the name SFFT. So from the SciPy FFT pack module, I import the entire SciPy.FFT pack module as SFFT, and within SFFT, that is my within SFFT there is one function called FFT. So FFT is actually the function which is available in SciPy FFT pack. SciPy FFT pack is given a short name SFFT, and I'm calling the function FFT, and YP will be my FFT. And as we know that YP is a complex number. Usually a Fourier transform is a complex number, so I take the absolute value square of this thing. That's called RYP. I've given the name, and I'm plotting RYP as a function of frequency. I'm not going to discuss how a frequency is generated. That is something you have to know, actually, the signal processing thing, the physics of the algorithm of signal processing, how the frequencies are leveled. So I'm just skipping it. But you can see the trick here. So I can see the Fourier transform. Oh, okay, I don't mind. See, If you can see the, I don't know whether you can see this. Let me see if I can. Size equal to 20. I think it's much more visible. Or shall I make it larger? Now it's visible. Now you can see the Fourier transform tells me that I have a peak at 1, I have a peak at 3. Look at my program. It actually consists of two signals at 1 and 3. So I got them back, 1 and 3. Okay, and figure 2. It's actually. Oh, I think I should have given up. ELT dot figure over here. Okay. Three figures. This is my mixed. This is the curve where it's a mixed signal which contains sine x plus sine 3x. Sine x plus sine 3x. If they're added in equal proportion, you get a signal like this, right? And that it's a period signal is actually exemplified here. You can see that actually it's a closed curve. Actually, it's a closed curve that shows me that it's actually a periodic signal, in the return map. And this is the Fourier transform that tells me explicitly that I have a peak at 1 and a peak at 3. Now, I want to play with this. This is simply for the mathematics students, that you know that if the frequency is this, what is this? Look at this. Now the frequency is sine x plus sine sq over 2x. What is sq over 2? Sq over 2 is square root of 2. Now I have frequencies like x and square root 2x. The frequencies are 1 and root 2. Frequencies are 1 and root 2. And what happens if I have a mixture of 1 and root 2? Right? So run this. This is my signal. From this signal, 1 and root 2, if you can clearly see that it is completely aperiodic. There is no periodicity. So imagine, I mean, know that if two signals are added together, and if the frequency ratios is not a rational number, 1 and root 2, the ratio is not rational. It's an irrational numbers. So they are called incommensurate frequencies. Incommensurate frequency. So the graph is not a periodic graph. You can see it's not a periodic graph. But one could have a periodicity coming from different other sources. Apparently it's a periodic graph. But how do I know that this periodicity is due to incommensurate frequency? How do I know that? This map tells me that it's an incommensurate frequency. So if I plot this return map, that also is not very simple. It doesn't tell me that it's a periodic function. It doesn't close back. It goes on doing different things. So it's not a closed map either. So these two things tells me apparently that it's a periodic thing. I mean, I'm confused. I want to really establish that these aperiodicity, the apparent aperiodicity is because of the incommensurate frequencies. That is I can do with the Fourier transform. Look at the Fourier transform. You get only two peaks, two sharp peaks, one at 1 and the other one is very near to 1.4, which is the value of root 2. That is how you can resolve that your apparent aperiodicity is not due to some other source. It's not a chaotic structure. It is coming from incommensurate frequency that you can simply find out by doing a Fourier transform. So that is something interesting. I think I can stop here and hand it over to Showman for the next discussion. Let me stop over here and hand it over to Showman. Stop screen presentation.
Thank you, sir. Thank you for this very interesting and very informative session. Now, I would like to ask Moumita Ghoshal to propose the vote of thanks. Moumita?
Before that, Showman, I think, wanted to do some session. What about that?
No, sir, most of the questions are answered. Some of the questions are transpose of matrix and inverse of matrix that you have, that is answered by you. And one thing is very important, one particular question to how to start Python programming. If you one of the participant has given this question, how to start Python programming from scratch. If a student doesn't know anything about Python, just if you can give some comments on that.
I think this is something that I've discussed in my first 2 slides. That first of all, if you have to decide which platform are you going to do Python with. Tell me which platform. If it is a desktop or laptop, then my suggestion is that you first download Anaconda. Then follow my guidelines. You can from slide 1. Just follow the guidelines, and of course there are many very well written tutorials in the net you can download, but my suggestion is that don't try to read much. I mean, learn it using your fingertips. But you know, I used to tell my students, I always tell my students, if they ask me any question about Python or any other programming, that don't ask me a question unless you have your finger on the keyboard. So you won't understand the answer unless you have your finger on the keyboard. So you have to listen by your fingers.
Okay. Yes, sir. So most of the questions are answered. Like one of the questions is why we use array over list. What is the advantage of using array over list?
Yeah. This is as I said that array has many advantages of vectorization. Like I showed you that in one of the slides. Let me show you that. These are confusing because they are listening it for the first time, so they can be confused. No, not this one, the slide. Let me just refer back to that. Recent. The beginning of this slide. Yeah. Look at this. A is an array, A is a list, B is a list. An is an array made from this list, Bn is another array made from this list. And then if I say An plus Bn, that will give me this array element-wise summation. That is something that we need very often, that element-wise summation. And you just give 2 star Bn. Every element of B is changed to multiplied by 2. So that is how you can. This is called vectorization. And if you write, say, sine of np dot sine of an, so every element of an is sine. Sine of every element of array is calculated. Those things are not possible with list. Right. So, for example, if I say an dot star 2, So every element of n will be squared, and you will get a new array. So these things are not possible with array. So if you want to do lot of mathematical calculations, then you will find array much more useful than a simple list. Shumit.
Okay, thank you. And most of the questions are answered. These are some questions which are left unanswered. So I request Morakhi madam to go on about the closures and others. Morakhi madam.
Okay,
Hello.
Momita, then please go for the vote of thanks.
Thank you, Moirakhi. It is my privilege to have been asked to propose a vote of thanks on this webinar. First, I would like to extend my gratitude to the speaker, Dr. Arunabha Bhavdikari and Professor Soumen Mukherjee for accepting our invitation. On behalf of the organizing committee and audience, I thank the speaker for all the valuable information they shared with us. I believe that the participants enriched with the knowledge gathered here. We have been fortunate to be assisted by our principal, Madam Dr. Soma Roy. You have been a constant support and you have given us a lot of encouragement. Thank you, Madam. Our heartiest thanks goes to the IQAC coordinator, Dr. Shayanti Mukhopadhyay Talukdar, for her masterly and well-explained presentation and motivation. We express our sincere gratitude to the organizing team members, convener of the SGC webinar team, Dr. Shampa Sarkar, and staff members. In this short time, you have made the best arrangement for this program. I must not forget to thank the people who have been the backbone of the event, our technical arrangement team. Without this dedicated and motivated team, it would not been possible to complete the preparation of this program in such a short time span. From poster preparation to till now, continuous support of the team make the webinar a great success. Last but not the least, I want to thank all the audience for sharing their interest in their program. Once again, thank you everyone for giving their precious time and making the webinar beautiful. Thank you. Participants are requested to fill feedback form and download certificates from the given link. Thank you. Stay safe. Have a nice day. Thank you all once again.
Thank you.
Thank you very much. Thank you.
Okay, then it's the end of the today's session. Thank you to all of you.